Hello viewers, welcome to GeeksforGeeks. In this tutorial, we will be looking at how to find the rotation count in rotated sorted array. Consider an array of distinct numbers sorted in increasing order. The array has been sorted anti-clockwise k number of times. Given such an array, we'll have to find the value of k. Let's look at an example. If the input array is this, our output should be 2. As initial array must be this, and we get the given array after rotating the initial array twice. This is another example. Our output should be 4 in this case. I will leave this example as an exercise for you. Try to visualize it. Let's look at a simple solution first. If we take a closer look at examples, we can notice that the number of rotation is equal to index of minimum element. A simple linear solution is to find minimum element and return its index. The time complexity of this solution will be big O of n. This is the code. We will take array and length of array as input. We initialize min by the first element stored in array. Min index will be used to save the index of minimum element. We will start a loop traversing through the array. At every iteration, we will check if our current min is greater than the ith element of array or not. If it is true, then we will store ith element in the min and store its index in min index. In the end of the loop, we will get the index of minimum element, that is min index, which will be equal to k. This is more efficient solution. Here we are using binary search. Here also we find index of minimum element but using binary search. The idea is based on below facts. The minimum element is the only element whose previous is greater than it. If there is no previous element, then there is no rotation. First element is minimum. We check this condition for middle element by comparing it with mid minus 1 and mid plus 1 elements. If minimum element is not at middle, neither mid nor mid plus 1, then minimum element lies either left half or right half. If middle element is smaller than last element, then the minimum element lies in left half, else minimum element lies in right half. Let's look at the code. We will take array, low that is first index and high that is last index as input. If high is less than low, then we will return 0, as in this case, array is not rotated at all. If there is only one element left, that is, high is equal to low, then return low. Else, if above two conditions are false, then find mid using this formula. Check if mid plus 1 is minimum element or mid itself is the minimum element. If mid plus 1 is the minimum element, then we will return it, and same for mid. If both are not the minimum elements, then we have to decide whether we need to go to the left half or right half. If element stored at high is greater than element stored at mid, then we will go to the left half, else we will go to the right half. As we are using binary search, thus the time complexity is big O of log n. Thank you for watching. Please leave us your likes and comments.